Welcome to Session 1, Introduction, a Number Trick for Algebra 1. These training videos are based upon the Elementary Algebra textbook, the original edition by Harold Jacobs, and the publishing company is W.H. Freeman and Company. However, even though these teaching videos are geared toward that particular textbook, you can still use these videos to assist you with whatever other textbook for Algebra 1 that you're currently using. And perhaps the best way to approach that would be to come up and take the different topics that each session covers and then go back and take those topic names and compare them against your table of contents for your textbook. And that way you can match up which of these sessions match up with whatever particular lessons that you have in your textbook. So before we go on though and delve a little bit into the first session here, I want to take a quick look at the title for each session to illustrate and help you understand what it is that you'll be viewing in the actual title itself. First thing you'll see is a session number. The session number just represents in sequence whatever the different sessions are. So obviously this is the first session we've done, so this will be session 1. And the next one will be session 2, session 3, and so on. The next thing in parentheses that you'll see will actually be the chapter number and lesson number within the Harold Jacobs textbook. In this situation, this first session is actually from the introduction to his textbook. That's why we have introduction here in parentheses. But for the remainder of the teaching videos, you'll see a chapter number and a lesson number. The last thing here in our title is the actual title of the lesson itself, a number trick. This is the topic that's being covered within the lesson, and this particular topic name matches the topic name that is found within the textbook itself. Okay, with that done, let's go ahead and move on here to an illustration and a quick discussion of what algebra really is. Up to this point, most of you are very familiar with adding, subtracting, multiplying, dividing, using fractions and decimals and percentages and different things like that. And you might be wondering, well, how is algebra different from these different types of things, functions, computations with math that I'm familiar with? Well, what we're going to find out is that you're going to continue to do many of those very same things in algebra. You're going to continue to multiply, add, subtract, divide, use fractions, decimals, percentages, and so on. But what makes algebra different is that it uses symbols to help you compute answers to problems. Well, what do we mean by that? Well, at this point, what I'd like to do is to just extract the idea that was shared in the Harold Jacobs textbook in the introduction, because I think it does a superb job of visually showing you and illustrating for you what algebra really is. So what I've done here is I've made up my own little number trick. It's very simple and straightforward. And then what we're going to do is use symbols to illustrate how we can find out the answer to this particular problem. Think of a number, and as we read these, go ahead and think of a number in your head. Think of a number. Add 4, subtract the original number that you thought of. What is your answer? Well, for many of you, you could quickly surmise that your answer is going to be 4. And it really doesn't matter which number that you thought of to begin with, your answer is always going to be 4. And the reason for that is that your original number here gets subtracted out here in our third step. And it's just going to leave you the 4 that you added to your original number. But let's go ahead and use some symbols to illustrate what's going on here. Well, I don't know what the original number was that you thought of, but in order to solve this problem, I don't have to know what it is, but I do need to assign it some type of symbol so that I can deal with it. Well, what I'm going to do is go ahead and use a square. A square being the same one that's used within the textbook within the number trick itself. Step 2 is to add 4. So to our original number, we are now going to add 4 to it. And each one of these dots or small circles represents one of the 4 that we're adding to our original number. So at this point, we now have 1 square and 4 circles. The last thing it asks us or tells us to do is subtract the original number that you thought of. Well, which of these symbols, the square or the circles, represents the original number that we thought of? Well, the square does. So I'm going to cross it out to represent that we're subtracting it or removing it. Well, after subtracting it, it's asking us what's our answer. Well, if we come over here and take a look, what do we have left? What we have left are 4 dots. What's our answer? Our answer is 4. Doesn't matter what the number was that we thought of, because in this particular number trick, our answer is always going to equal 4. What if your number was 10? Well, 10 plus 4, add 4 is 14, and then subtract the original number, 10. Well, 14 minus 10 is 4. And no matter which number you choose, you're always going to get 4. So we were actually able to solve this particular problem, even though it was very simple, without even having to know what the numbers were. We just strictly used symbols. What we're going to do is use the same type of reasoning and the same type of number trick, but add a few more steps to it and show you a little bit further how algebra works. Once again, just using symbols. And we're going to use the same ones that I did in the previous example, a square in circles. So once again, pick a number. Add 5, multiply by 2, subtract 6, divide by 2, and then subtract the original number that you thought of. So let's take these one step at a time. Pick a number. Well, what I'm going to do is represent that number with a square. That's step 1. Step 2 is that we now need to add 5 to it. So the circles, each of the circles dots represents one of the 5 that we're adding to it. Next step is to multiply by 2. Well, what we have to remember is we're going to have to multiply each different symbol here that we have by 2. So if we have one square and we multiply that one square by 2, how many squares will we now have? 2, because 1 times 2 is 2. Well, we now have to come to our 5 dots and multiply that by 2 as well. Well, if we take our 5 dots and multiply it by 2, how many dots do we now have? Well, we have 10, because 5 times 2 is 10. So after our third step here, we now have a total of 2 boxes and 10 circles. Our next step says to subtract 6. So I'm going to come over here and X out 6 dots. That represents the 6 that we're subtracting from our number now. Next, after subtracting 6, it now says to divide by 2. What I'm going to do is at this point, instead of crossing out some more and getting a little bit possible confusion going on, I'm just going to go ahead and select a different color here. And we're going to write the answer that we have after this step over here in blue. Okay, we're at this step here, divide by 2. Well, if we have 2 boxes and we divide that by 2, how many boxes do we now have? Well, we have 1 box left. 2 divided by 2 is 1. Well, we also have 4 dots. Well, if we take those 4 dots and divide it by 2, how many dots do we now have left? 2, because 4 divided by 2 is 2. So then everything over here is now gone, and what we're left with after our divide by 2 step is now 1 box with 2 dots, or 2 circles. The last step here says to subtract the original number that you thought of. Well, which of these symbols represents the original number we thought of? Well, the square does. So I'm going to go ahead and cross it out. It then asks us, after we have subtracted our original number, what is your answer? Well, what do we have left? 2 circles. And those 2 circles represent our answer of 2. So we were able to show here, through using symbols, that the answer to this particular problem is 2. And the trick, and once again, the neat thing about this is it doesn't matter what the original number was that you thought of. If you perform these functions or these calculations to it, you're always going to get an answer of 2. I'll just pick a couple quick examples to illustrate before going over the final review point of this particular session number 1. Let's say our number was 10. Pick a number, 10. Well, let's add 5 to it. 10 plus 5 is 15. We'll multiply by 2. 15 times 2 is 30. Then subtract 6. 30 minus 6 is 24. Then divide by 2. 24 divided by 2 is 12. Then you're supposed to subtract the original number that we thought of. Well, the original number was 10. 12 minus 10 is 2. And there's our 2 dots. And we could have also picked the number 1 or even 0. Let's just pick 0. be a little bit different here. Pick a number, 0, add 5. Well, 0 plus 5 is 5. Multiply by 2. 5 times 2 is now 10. Subtract 6. 10 minus 6 is 4. Divide by 2. 4 divided by 2 is 2. Subtract the original number that you thought of. Well, that was 0. So 2 minus 0 is now 2. Once again, that's our 2 dots there. It represents our answer of 2. So then, algebra is a system of performing mathematical computations where you don't have to always have the exact numbers of everything that you're computing together. You can actually use unknown numbers and represent some of those numbers with symbols to actually calculate and determine what the answer to the problem is. So for session 1 review, the heart of algebra involves using symbols to solve arithmetic problems, as opposed to always having to have exact numbers before being able to solve these problems. And as this particular session illustrated through the number tricks, we were able to use symbols, squares and circles, to help us determine what the answers were to some particular mathematical problems. Lastly, what we're going to find out in the subsequent lessons is that algebra had to come up with a system of which symbols that they were going to use. After a while, if we were to try to represent everything with squares and circles, as I did here in this first session, it would get a little impractical and cumbersome. So what they have done in algebra is they've determined we're going to use different letters of the alphabet to represent unknown numbers, and those will be the symbols that we'll be using. So then, that's the quick review of what algebra really is. Algebra is using symbols to help solve arithmetic problems.